Hello everyone and welcome. In this video we're going to go through kind of the conversation on the ANSI B11.TR3, so it's the technical report number 3 that's in association to the ANSI B11 documentation. And again, the ANSI B11 documentation is an ANSI standard that goes through machine and equipment guarding, and what type of guarding for what type of equipment, and etc. This particular technical report or technical review that goes along with the ANSI B11 standard talks primarily about the risk assessment and the risk reduction and how we're going to go about doing that. I would strongly encourage you, if you're watching with this video, is to have that report in front of you and then kind of read through along with us. If you don't have it, we do kind of cover the highlights and the high topic points of the ANSI B11.TR3 here, and so you wouldn't necessarily need to obtain that, but if you already have it, it's great to follow along. It's a very quick read, and it goes through kind of a general understanding of the parts of the risk assessment as well as what we can do to reduce those risks. So to start off, what's the report about? It's the risk assessment information. It's the information included or that should be included as a base standard within your risk assessment. It also includes some items that we can use to reduce the risk, as well as our goal of achieving whatever is our tolerable risk level. So some companies have a zero risk tolerance level, and then some have a higher tolerance level depending on what it is. Obviously, the goal within the technical report as well as in the ANSI B11 is to reduce the risk to no risk. It's understood that that is not always an option, nor is it truly capable of being achieved. So looking into the document, we kind of skip through quite a bit of the very beginning because we go through kind of the very first introduction as well as into some of the definitions that would be helpful through the report itself. Again, if there's some questions you have along the way that come down to the definition, again, I would strongly encourage you to get a copy of this and then go ahead and go through that. For the sake of our video here, we're not going to go through those definitions, as in truthfulness, you can look those up on your own online for the most part. So we kind of have some steps that need to be gone through in the process of completing the risk assessment, and we're just kind of going to highlight and go over those real quick. So the first one, we need to gather our information. So it's kind of our gathering our intel step. So we need to know what kind of information about the equipment. We need to know information about the operations that are going to go along with the equipment, as well as those that would be using the equipment. We have to identify every part of that, every part of the limits that we're going to run this machine to. So are we going to run this at 20 parts a minute, or are we going to run it at 50 parts a minute? We need to know that kind of information, as well as what's going to happen when we get into the point of having to work on the equipment. So when a valve breaks or when a cylinder stops functioning properly, we need to know those limits as well. With that, then we're going to go down and we're going to document all of those hazards. We need to go through every step-by-step piece, and we need to know every hazard that's associated with that. So back to kind of our discussion, so if we change a valve out, if we change a cylinder out, we need to know the hazards that may be associated with that kind of information. If we're kind of a press system or something like that, we need to know what would be associated with that as well. So do we have to have a tool to pull it out of the press? Do we just go ahead and stick our hand in there? What kind of hazard is associated with that kind of a function there? And then number 4, like we talked about in our first slide here, is that we need to identify all of those that would work with the equipment. So that goes all the way from your operations folks, so your operators, your setups, your other bottom level people that are going to work with those machines on a daily basis, all the way up to your top managers that may just be walking by the equipment. Will they ever touch the equipment by any reason, or for any reason, or by any means? We need to know what maintenance would have to have, or what they would be doing with the piece of equipment, what any other type of technician would be doing with the equipment. We need to know what our engineers are doing on the equipment. And again, are we bringing out administrative personnel that would be touching this equipment for any reason whatsoever? And if that's the case, then we need to associate those risks that are possible there. And then we need to determine, step 5, if our risk is tolerable or not. So we've identified all of our risks. We've identified all those that would be in that moment there, but is that risk considered tolerable as it stands? And if the answer is no, then we need to go ahead and go through this process of trying to reduce that risk so it's a tolerable level, or it's a no risk at all situation. Some of the items that we would probably want to include in our risk assessment, and again, this is just a very high level understanding of items that we would want in there, is we want the drawings or the schematics of the machine. So all of your layouts, all of your standards, all of that information that has anything to do with that piece of equipment. So everything down to the bill of materials, all the way to the pneumatic prints, the mechanical, the electrical prints, all of that information. We would want to take all of that information in and bring that into our risk assessment. We'd want to identify all sources of incoming power. So is it a mechanical force? Is it spring loaded in that mechanics? Is it a hydraulic? Is it there's some kind of chemical transfer, heat transfer, any type of thing like that? I mean, we may need to consider the ideology that if it's like a glue dispensing machine and it's a two-part glue mixture, we need to identify that those two glues mixing together, and whether it be a static or dynamic mixing system, will produce some sort of heat that needs to be identified. So there you have a thermal type of energy, and obviously we have electrical energy that needs to be identified generally. It's helpful to know our equipment layout within our facilities, within our plant layouts. It's important to know that because the ideology that if we put like a type of interlocking guard door on this, is that going to hit like an outside wall? We need to identify those types of issues where instead of putting maybe a guard door there, we might have to consider putting in a light curtain to reduce that issue that would pose itself there. Then we would look at incident history reports. So have we ever had a history of this type of machine causing us damage or causing us problems before? Have we ever gone through a risk assessment on this type of equipment before? A lot of facilities, especially in the modern era now, we've come to the realization that keeping equipment standardized throughout a plant is very helpful. So keeping incident histories can be very useful along that way too. We need to also identify our equipment limits. So again, we go back to the standards of what can we make this equipment run to, how far can we run it. So again, if it's only standardized to run it at 20 parts a minute, but we're going to try to run it at 35 parts a minute, we need to identify that as an equipment limit, but we need to identify that we're going to try to increase our limits. And so we need to bring that into consideration greatly. And we also need to consider if that's going to be something that we're going to change there, so we're going to bring it from our standard at 20 parts a minute to 35 parts a minute, which is well within reach of achieving. We need to understand that that change there could change the other pieces of the puzzle of this risk assessment. So we need to take those into consideration as well. And then lastly, we need to understand our equipment life cycle and lifespan. So is our equipment capable of being made safe, or is it kind of outdated? Does it need to be brought to a more modern era of equipment interface and stuff like that? Is that going to jeopardize our product? Is that going to jeopardize how it works? Could that cause more risks itself, more hazards? So those are things we need to understand, as well as additionally in the equipment life cycle, is it really cost effective to go ahead and upgrade our safety side of something like that? Or is it better to just go ahead and write that off and depreciate it out as it's already been depreciated, and just push that out and go ahead and order a new piece of equipment in? So those are, again, other things we need to consider on the equipment life cycle. We need to identify and understand our user training. So we need to identify all the users that would, again, come within contact of the equipment, and we need to determine what kind of training they would need. So again, is our sales rep or our administrative folks, are they going to have any type of contact with this equipment? And if so, what kind of training are they even required to have? I mean, it's obvious that we understand that the operators are going to be working through that, and they need to be identified as a user that is going to need some serious training, as well as some of our maintenance personnel need to understand safe practices. And if in the FDA side of it, they need to understand their good manufacturing practices as well. So those are some other things that we need to really take in, is the training aspect of this. So with that being said, then we would move on to understanding that our tasks and hazards are identified. So we identify, again, all tasks and hazards that are associated with the equipment, all of them that in any way, shape, or form could affect this equipment and how they're affecting the equipment. We determine what hazards are present and at what level they're present at. And we identify any type of misuse that may occur with the equipment. Improperly trained folks, people that think they know what's going on, especially those that think they know everything and are going to tell you how to operate it. You need to identify that they could be a problem, and they will be a problem. It's guaranteed. And I've always said this before, and I will continue to say this probably until my dying breath. If it can be defeated, it will be defeated, because that's just the way operators are, and that's the way mechanics are, that's the way technicians are. I've been on that side of it. We have to defeat things at times, but that's not an acceptable practice. So understand, improperly trained, and identify any type of misuse that could occur, and do something to countermeasure that misuse or improper use of the equipment long before it ever happens. So take that into consideration when you're doing your risk assessment as well. We estimate our level of risk when we go through this. So by doing so, we're going to ask ourselves, and I have a list of some of the questions here, and it goes a little deeper into that within the technical report. Again, if you want to take the time to go through that, it'll definitely give you some more advice and understanding along the way on that. But I'm just going to kind of go over some high-level stuff here, where it's how severe would the harm be if it did occur? And how likely is this harm to occur with this type of equipment? At what level are the operators exposed to the harm? Is there a history of this level? Does the environment add to these levels? Any type of human error that could occur? What level of safety controls will be used on this equipment? And that could go everything from mechanical to electrical to pneumatic, hydraulic, whatever that would be. Will this system ever be defeated? Again, we talked about improper use of the equipment. We need to countermeasure that long before it ever happens. Can this system be protected? And again, that's the countermeasure completion there. But we bring all of these into this, and then we list out our type of severity of harm. So what we determine is that if it's very likely and it could cause you a high death, it's a high risk and it needs to be brought down. And most of the time, and in fact, I believe even in the technical report, it tells us that anything above a low risk is pretty much considered unacceptable. So we need to bring all of our risk down to somewhere between low and negligible. So understanding that if you have something that's very likely to happen and it could be a serious or moderate issue, we understand that that's going to be a problem that we need to reduce and identify it and reduce it. If it's likely to happen, it's catastrophic, it's going to cause somebody a death, or it's going to cause like an amputation of some sort, or it's going to cause a laceration, we understand that those could be an issue that we need to bring that down as well. If it's highly unlikely that it'll happen, but it could potentially cause, again, death, limb amputation of some sort, or major laceration, we understand that that still as well could become an issue that we need to address. If it's almost never ever going to happen, not in a million years could this really happen, but it's somehow in a 0.0001% chance it could eventually happen, and it causes some other thing, we understand that those are considered very low risks, and could potentially need to be safeguarded. Again, if you have a company that's we're a no risk operation kind of thing, again, we understand that, so we take that into consideration, and we have to identify that as a level that needs to be addressed. So, how do we reduce our risk? That's the truth. So, 9 times out of 10, the way we really need to do this, especially with new equipment, is we design, we bring the risk assessment into the design. So, our very first step here is we design the hazard out of the equipment. So, we totally annihilate it by putting interlocks and guard doors and stuff like that into the design of the equipment. So it's totally eliminated. Even on old equipment, we have the ability to upgrade and update things like that, so we design the hazard out of the equipment. We can't entirely do this one, but we're able to do certain safeguards that can work with that. The other option is then we move into the next step, where we create guarding to protect the users from the hazards that are present. So whether they be high, medium, or low, we annihilate them by pushing it out, by protecting the operators from that. And that is usually our option. That is probably the number one that most of us will use, other than administrative controls, is we will create some type of a guard system that will protect the operators from that type of a hazard. And that guard, again, could be any type of guard door, so a hard guard kind of thing, a mechanical separation between something, some type of protective cover, an interlocking guard door. And we'll talk a little bit about interlocks and stuff like that when we discuss our technical report number 4, and items such as that. And then lastly is our admin controls for protecting the users. So this is, again, is like telling your administrative folks that they're not allowed to touch equipment when they walk across the factory floor, or telling your operators they have to use a tool when they're popping things out of maybe a press or something like that, or you have to wear gloves when you're handling glue because the glue has that thermodynamic discharge of high heat, etc. So that's your admin controls for protecting that. A lot of times your PPE is somewhere in between there as well. So we evaluate after we have completed the risk assessment, and after we have identified those hazards, after we have figured out how we're going to countermeasure those issues, and we reevaluate. So after all of our changes, we reevaluate and we reassess our system. So did our changes present any type of new risk? So again, we talked about sometimes putting guards on old equipment causes more problems in the future or in the new equipment that we're working with. So is it truly that we have aided ourselves, or have we caused ourselves greater issues by completing this type of a guarding system? Does our guarding present new design errors? Is all equipment readily accessible? So the NFPA 70, or the National Electrical Code, requires that we have access to all of our electrical panels. So it's roughly, depending on the power and the voltage rating of the cabinet and stuff, most cabinets are required to have a 36-inch clearance between the front of the cabinet door to the back, as well as having 28 inches from side to side as allowing access to the cabinet. So a common theme that I've seen in a lot of older plants is they put some type of a guard over any type of an electrical cabinet. So it makes maintenance technicians have to rip the guard off just in order to get into an electrical cabinet to change out a fuse or any of that type of instance. So does that present a new hazard or a new issue for us in the future? Or did you put guards over a valve manifold and you need to be able to access those valves in a readily accessible location? Yeah, it doesn't present necessarily an error or a hazard particular to say, but it does present an issue of not making it readily accessible. So those are things we need to really kind of reevaluate and consider, especially when guarding old equipment through our risk assessment. And then if we find that there are new risks present that need to be done, we keep the old risk assessment and we complete a new risk assessment with those changes in mind and identifying everything we've already talked about, and we recomplete it here again. All in all, we document, document, document. Everything should be documented. I don't know who in your company would be in charge of keeping that, but generally it's kept through your EHS department, or your engineering department will keep some of this information. But make sure you document, document, document. Too many companies are in fallacy because we fail to document all of this information. So, with our documentation, always keep a completed risk assessment with the identified changes and their evaluation. All identified hazards should be included within your risk assessment. All the data associated with the identification of the hazards, so any time studies, reports, any of that information. All the protective measures used to safeguard that equipment should be identified within that risk assessment, as well as any other additional documentation identifying those risks and how you protected those. At what tolerable risk did you achieve? Did you get all the way down to a tolerable risk level of a low or negligible, or did you reduce it altogether? Whatever you hit, that should also be documented within your risk assessment, as well as any other adjustment or change. So if you deviated from what your standard is, you need to document what that tolerable risk level was and why it needed to be changed. And any residual risk, again, not fully accounted for, needs to be documented. And we've gone ahead and included in this last slide here kind of a rough idea of a risk assessment. And later on in another video, we'll go through how to fill out a risk assessment so that we kind of have kind of a rough understanding and a rough idea of what to do with that. But this kind of gives us just kind of an overview here where you have the activity, the hazard identified, as well as what risk level and what severity level it's going to occur at, and then you are going to multiply those together, and then you end up with what type of risk factor that would be. So anything within a certain range ends up in a medium risk level or severity, and then you have anything that's over a certain level is a high severity, and then anything that's a low severity. And then anything that may not reach that level as well would just be considered negligible. And then how are we going to adjust this? What additional controls are we going to put in place? And how would that bring us down to a level that's considered safe? And with that being said, then we would achieve a residual risk. And again, we'll go through all of this at a later date in a little more detail. So just kind of wanted to give us kind of a rough understanding. But that concludes everything that I have for us today on the ANSI B11 technical report number 3 on how to use a risk assessment to identify some of our risks and hazards and reduce them. So thank you all for watching, and stay tuned for our additional videos.